Alright, so in this video we'll be covering the basics of logarithmic functions. Starting in section 4.2, we're going to see a lot more with logs the rest of this chapter, less so with pretty much covered what there is to know about exponentials. So exponentials, and I've kind of put a basic exponential equation up here, exponentials and logarithms are 100% related to each other. So if you notice this equation on the left, 2 to the third equals 8, so 2 times 2 times 2 is 8. And then you notice this is a log, and when we say this, we say this is the base of the log, the little number here. Log base 2 of 8 is 3, but what you notice is there's definitely a relationship between these two setups. We see the same numbers involved. Basically, when I write the phrase, the mathematic phrase, log base 2 of 8, and if I didn't have this equal sign on here, what I'm really asking is the base of the log. I'm saying 2, this is going to equal to 2 to what power is equal to 8? 2 to what power is equal to 8? That's kind of what this is going to translate into. So a log is basically, the answer to a log is the power. So the log is saying, what power did I need to raise that base to in order to get 8? So 2 to what power, that's why the answer is 3. So we're just going to go through a couple of examples here, and this is going to be a pretty short video, but we have log base 4 of 64. So the question is asking 4 to what power is equal to 64. So we could rewrite this. So the question's asking, it says this equals to what? And it's looking for, that question mark is what's the power? 4 to what power is 64? Well, 4 times 4, that's 16. Times another 4, well, that would be 64. So this is 4 to the third power. So the question mark we're looking for, we said the actual answer, log base 4 of 64 would be 3, because that's the power you raise 4 to get 64. So how about, you might want to pause this and try this one on your own at some point. But again, this question is saying log base 10. So it's saying 10 to what power? This is equal to, let's just start using some variables instead. 10 to what power? 10 to the x power. What power should we raise the 10 to get to 1,000? So the log it's relating exponents, but we're writing them in a different way. And why we're writing them in a different way, we'll kind of see as we go on. But logs and exponents just saying the exact same thing, just in a slightly different format. So 10 to what power gives you 1,000? Well, 10 times 10 is 100. 10 times 10 times 10 is 1,000. So it looks like, again, we have an answer of 3, but x here would be 3. So log base 10 of 1,000 is equal to 3. Okay, so how can we make this maybe a little bit harder? Same questions being asked. Say this is equal to, we want to know what it's equal to. We're just asking, what power do we raise the base to? So 1/2, what power would I use to get to 1/8? So 1/2, at this point, the best way we have is to just multiply out and see what power. So 1/2 times 1/2 is 1/4. 1/2 times 1/2 times 1/2 is 1/8. So again, and this is just a coincidence with all these problems. I didn't necessarily intend for all of them to equal 3. That's just how it's working out. So you're saying base to what power gives you the 1/8? 1/2 to what power is 1/8? So let's switch this up a little bit and kind of realize, what is this saying? What is a different setup saying? Still Same information. X to some power is going to equal to 27, but this time we have what it's equal to. So this 3 over here is the power. The base of your log is also the base of your exponent. So this is, we're interpreting this, it's saying x to some power, and that power happens to be listed for us as 3, is 27. So x to that third power gives you 27. How can we figure out what that number is? Well, we could think about it logically, or we could actually solve this equation in this case. So we have a way to get x alone, and that's to take the cube root. The cube root, in this case, is 3. So log base 3 of 27 would equal 3 to fill in that statement. Can we use logs on everything? Well, there's some different setups, and so we have this particular setup we just talked about. There's some, again, we're kind of just getting into some of those trickier areas that are a little less straightforward. So this is asking 100 to the what power equals 1. So what does log base 100 equal? It equals what power I would take 100 to equal 1. Well, you think to yourself, what power would give me 1? That question mark, or if I change it to an x, that question mark, what power would I have to change 100 to, or raise 100 to? It would have to be 0. So x is going to equal 0. So log base 100 of 1 equals 0. It's saying 100 to the 0 power. What power? The answer is what power? The power is 0. Okay, what's this one saying? It's saying take 2 to some power. How do we get 0? Raising 2 to a power, how do we get 0? Well, even if I raise 2 to a negative power, let's say I raise 2 to the negative third power, that's just 1 over 2 to the third, remember, so this is 1/8. If you remember from our exponential function, is there a way to make 2 to a power equal to 0? No, that's our horizontal asymptote. It never gets to 0, so this would be not possible. And this is where we'll start on Friday. We're going to be working on graphing them. So right now all you need to know is the basics coming into Friday.